Let's take a look at the nearest neighbor algorithm. Starting at Seattle, find the circuit that results from the application of the nearest neighbor algorithm. So we want to start at Seattle. Now the way the nearest neighbor algorithm works is from Seattle you look at the closest, in this case the cheapest flight. So we have 120, we have 140, we have 145, and there we go, we have 70. So we'd want to go to Seattle to LA, and I'm going to put 70 right over that so it's easy to see the weights when we're done and add them all up. Now that we're in LA, we can't go back to Seattle because we haven't visited all the cities. That leaves 150, 170, and 100. 100 is the minimum, so we go from LA to Chicago. And that cost is 100. Now we're at Chicago. We can't go back to LA. We can't go back home yet because we still have 2 more vertices. So we have the 165 to Dallas, or the 75, oh, that's the cheapest, going to Atlanta. That's 75. Now we're at Atlanta. We still have Dallas to visit, so there's really only one place left. So what we've done so far is we've gone this direction, then here, and down. And now from here, we can't go back to any of the old ones because that would complete a circuit before we're visiting all the vertices. There's only one move left. Go to Dallas. So then to Dallas, and that's going to cost 85. And once we're at Dallas, the only thing left to do is get back home. That's going to cost 120. So the circuit is Seattle, LA, Chicago, Atlanta, Dallas, Seattle. If you need to know the weights, then you would just add up the weights. In this case, it would be the minimum cost. And that would be $450. Now you do have a choice. You could also list this going in the other direction. We could go from Seattle to Dallas to Atlanta to Chicago to LA back to Seattle. If we were to go fly in the opposite direction, we would make the same circuit, we would hit all the same vertices, and we'd pay the same fees. And so there's actually 2 different ways to write the circuit in what I would consider forwards, since we created it with the nearest neighbor algorithm, or backwards. They will both be accepted on the homework, on exams, etc., because they are both correct. Okay, go ahead and pause the video as you work on the problems on the right. So you can either have A, D, C, B, A, or in reverse, A, B, C, D, A. And the minimum cost is 26. And on the bottom one, you could have D, A, C, B, A, or A, B, C. I've got that wrong, sorry. B, C, D, or D, B, C, A, D. And that cost would be 20. So notice that the nearest neighbor algorithm doesn't give you the same answer. It depends on which vertex you start with. Now, the nearest neighbor algorithm is a heuristic algorithm. It's not designed to give you the best answer. It's designed to give you a fast and good answer. Best? No, not necessarily. Maybe you get lucky. Fast? Yes, it's easy to do. So, we can apply the nearest neighbor algorithm starting any individual vertex. And if you want to, you can start with all the different vertices and get even a better answer. Right now, I would say 20. One of these 2 circuits is probably one of the best answers we can get. But who knows until we look at them all. Hope this helps.